Hey everyone, and welcome back to InfoPod. I'm your host. Today we're doing a deep dive into something that, well, it affects quite a few people. Penicillin allergies. We're going to try and unpack why this really important antibiotic, one we use all the time, can sometimes cause pretty serious reactions. Think of this as your guide to understanding penicillin allergies.
Yeah, it's fascinating, isn't it? And something our sources really highlight right off the bat is this kind of duality with penicillin. I mean, on one hand, it was absolutely revolutionary, a total game changer since, its wide use back in World War II saved countless lives. But then on the other hand, it's also like a major cause of drug allergies. Some studies we looked at suggest it might be involved in a significant number of drug allergy deaths each year. Makes you ask, what's really going on there?
Exactly. And it's not just like a simple side effect, is it? Our materials are pretty clear that a penicillin allergy is quite specific. It's not the drug itself being toxic.
Precisely. That's the key takeaway. It's an immune response. Your own body's defense system.
Yeah.
It mistakenly tags penicillin, or really a version of it that's been slightly changed in the body, as something dangerous, an invader. And that's, fundamentally different from just drug intolerance, like getting an upset stomach.
Right. So it's not like taking too much medicine and feeling sick. This is the body actively fighting back.
That's a really good way to put it, yeah. Now, here's where it gets interesting and maybe a bit counterintuitive. Most drugs, penicillin included, are actually quite small molecules, chemically speaking. And usually on their own, they're too small to really get the immune system's attention. They can't usually trigger a full-blown allergy by themselves. But penicillin, it has this kind of sneaky way of making itself visible.
Sneaky how? What does it do?
Well, what happens is penicillin can chemically react with proteins that are already just floating around in your body, normal body proteins. And this reaction, this binding, creates a new, bigger structure. It's often called a penicilloyl protein derivative. Think of it like, okay, the penicillin molecule is a small Lego brick, doesn't look like much alone, but then it clicks onto a much larger protein structure. Now you've got this bigger combined thing that suddenly looks, foreign to the immune system. And the specific part the immune system latches onto is called the penicilloyl group. It acts as what scientists call a hapten.
Okay, so the small brick attaches to something bigger, and suddenly the body's security system goes, whoa, what's this? Intruder alert.
Pretty much, yeah. That's the trigger.
So what happens after that first alarm bell rings?
Right, so this first encounter, this initial recognition, it leads your immune system to start producing specific antibodies against it, particularly a type called immunoglobulin E, or IgE. These IgE antibodies then circulate around and they stick themselves onto the surface of specific immune cells, mostly mast cells and basophils. Ah, okay.
And interestingly, this very first exposure, it often doesn't cause a massive immediate reaction. It's more like a sensitization phase. Your body is basically learning to recognize this thing it thinks is a threat. You might get some mild symptoms maybe a week or so later, like hives, perhaps a fever, swollen glands. As some of our sources mention things like that.
So that first time you take penicillin, your body might just be setting the stage, like laying down tripwires for next time.
Exactly. That's a perfect analogy. The real danger, the serious reactions, typically happen on subsequent exposures. If that person takes penicillin again, those IgE antibodies that are now sitting there ready on the mast cells and basophils, they recognize that penicillin derivative almost instantly. And that recognition triggers those cells to just dump a whole load of powerful chemicals. Histamine is a really big one here. Histamine, right. And that's the chemical behind all the classic allergy stuff, isn't it? Itching, the watery eyes, the swelling, that kind of thing.
Precisely. That's histamine doing its work. But in severe cases, it doesn't stop there. This chemical flood can rapidly escalate into anaphylaxis, which is a systemic reaction affecting the whole body. It can absolutely be life-threatening.
Wow.
Our source materials really emphasize how fast and severe anaphylaxis can be. They talk about, swelling of the throat, making it hard to breathe, swelling around the eyes, a sudden, dangerous drop in blood pressure. It's a genuine medical emergency.
Yeah, that sounds incredibly serious.
Yeah.
And that's where, as our sources point out, epinephrine or adrenaline becomes so critical as the immediate treatment.
Absolutely essential. Epinephrine works fast to counteract those effects. It helps raise blood pressure back up, it opens the airways, it reduces swelling, and it actually suppresses the further release of those chemicals like histamine. It can literally be a lifesaver in that situation.
Yeah.
And the materials also rightly stress how important it is for anyone with a known serious drug allergy, especially if they've had anaphylaxis before, to wear some kind of medical identification, a bracelet, a necklace, something.
Right, so healthcare professionals know immediately about the risk.
Exactly. It ensures they're aware, even if you can't tell them yourself.
It really hammers home the need to know your allergies and make sure that info is accessible. Could literally save your life.
And, if we step back and look at the big picture for a second, the fact that penicillin has been used so incredibly widely since the 1940s, that likely contributes to why it's such a common allergy. Just statistically, more exposure across the whole population means more chances for this sensitization process to happen in people who are susceptible.
Makes sense. More lottery tickets sold, more winners or losers in this case.
Kind of, yeah. And our sources do mention that researchers are looking into genetic factors too. Some people might just be genetically predisposed, more likely to develop these allergies than others. It's complex.
Fascinating. Okay, so just to sort of boil it down for everyone listening, a penicillin allergy isn't the drug being poisonous. It's your immune system mistaking a slightly altered form of penicillin for a threat and setting up defenses. And crucially, the next time you encounter it, the reaction can be much, much faster and more severe.
That's the core of it. And this also touches on something else important, something implicitly raised by our sources. The whole challenge of antibiotic resistance. As bacteria become resistant to older antibiotics, we inevitably rely more heavily on others. This could potentially increase the chances of new allergies developing or make existing ones like penicillin allergy seem even more common relative to other treatments. It's a complicated web.
That is a really crucial point to consider, especially looking forward. Well, thank you so much for walking us through all that. It really helps clarify things. And for all of you listening, if you found this deep dive into penicillin allergies helpful or interesting, please do take a second to hit like, maybe leave a comment, or share this discussion with someone you think might benefit. And of course, make sure you subscribe to InfoPod. That way you won't miss out on our future deep dives. Thanks for tuning in.